The searching is the process of finding out an element in a given array. An array is a data structure that is supported to store more than one value of similar type of data items. The linear search criteria is always it searches from the first position to the last position. Hello everyone, it is Dr. Ravikumar YB. Today we shall learn about the searching algorithm. Which are the different types of searching algorithm basically needs to be understood by the students in the machine architecture and assembler. In this unit 1, you will come across two different types of searching algorithms. The first one is linear search. The second type of searching algorithm which you have in the syllabus is binary search algorithm. Let me take you into the details of searching algorithm. That is, the searching is the process of finding out an element in a given array. There are two types of popular algorithms. The first one is linear search, second one is binary search. In case of linear search, you will come across the list of elements which is not at all sorted. I am using the word sorted. The word sorted stands for keeping the elements in an increasing order or in the decreasing order. For example, sort is the technical term I am using here. That is, if the elements are stored in this manner, these are called as sorted in ascending order. Suppose if the elements are sorted in this manner, we say that it is sorted in descending order. Suppose if I have the list of elements in any random manner, that is 10, 30, 20, 10 or 40, 50. These are called as an unsorted array. Now, you will see that the elements of this are in increasing order, that is 10, 20, 30, 40, 50. Now in the second list, you have the elements which are in the decreasing order, that is from highest to lowest, that is 50, 40, 30, 20, 10. Whereas in the third case, you have the elements which are stored in the random fashion, that is 10, 30, 20, 40, 50. So these are called as an unsorted array. This is called as a sorted array, sorted list of elements. If that is the case, how can I perform the search operation using the strategy linear search? See, the linear search is a very basic and simple search algorithm. I am using the word very basic and simple searching algorithm. In linear search, we search for an element or value in a given array by traversing the elements right from the first position to the last position of an array. I am using an array here. An array is a data structure that is supported to store more than one value of similar type of data items. Please remember it carefully. If I want to store the similar set of data items in an array, I can have it. There is a possibility. But if I want to store the dissimilar type of data items in an array, it is not at all possible in C++ or Java or any of these types of languages. Now, in this array, suppose if I have an elements in this order 20, 30, 40, 50, 60, then I shall represent it to the desired location by indexing it to 0. This as first position, second position, third position, fourth position. This is called as the fifth position. And if I give a name to this array, it can also be called as A. Now I have totally 6 elements in this array. All these elements are of type similar type of data items, that is of type integer. Suppose if I want to store a floating point type of data items, yes, that is also possible. But the only criteria, the only desired requirement is to have the similar type of data items. Whether I can have full data items or every data item is of type integer, or every data item is of type floating point, every data item is of type character. Now in this case, I have data items of type integer. In this case, if I want to search the elements or the desired element in the list, I have to keep on searching from the first position, that is from year to the last position. Since the array is started from 0, that is from 0th location, I will call this as the n-first location. I will call this as n-2 location. This as n-3, n-4, n-5, or in other words, n-6. If I substitute the value of n is equal to 6, totally how many elements are there? 1, 2, 3, 4, 5, 6. If I substitute the value of this, 6 minus 1 is equal to 5, 6 minus 2 equal to 4, 6 minus 3 is equal to 3, 6 minus 4 equal to 2, 6 minus 5 is equal to 1, 6 minus 6 equal to 0. So am I getting the index of this? That is 0th location. 1 is matched with 1, 2 is matched with 2, 3 is matched with 3, 4 is matched with 4, 5 is matched with 5th element. So with this, I am able to find out the indexes of that array items. If that is the case, I shall search from year to the last item through these indexes. If I say that A of 0, that refers to value 10. That is, if I say that A of 0, that refers to the value 10. Similarly, A of 1, that refers to the value 20. Similarly, A of 2, that refers to the value 30. Similarly, A of 3, that refers to the value 40. Similarly, A of 4, that refers to value 50. A of 5, that refers to value 60. If I have these elements in an array, then I can access these data items from first to last, and I can search for the desired element in an array. If you look at this example, in this case of linear search, you have totally 9 data items: 10, 50, 30, 70, 80, 60, 20, 90, 40. In this case, in this example, I want to search for an element 30. I can search for it right from the leftmost position, that is A of 0, then A of 1, then A of 2, so on like that. If that is the case, what has to be the logic of that? The logic of that will be like this. We will search for an element iteratively. That is, if I will write down the condition, that is A of 0 is equal to the desired element, we say that element found. Else we say that the element not found. This is when the value of a of 0, that is 10, is equal to 30. Is it possible? 30 is not equal to 10. So obviously it comes to the else part. But that must not happen. I want to iterate it over and again. So I will have a of 1 next time. What is a of 120? 20 is equal to 30? No, again that is not possible. Again, I have to increment it by 1. What has to be the value of this a of 2? That is, a of 2 is 30. 30 is equal to 30. Then I have to display this message, element found. If that is the case, what has to be done? Initially it was 0, then it is 1, then it is 2. So it is incrementing 1 by 1. So let me have one for loop for I is equal to 0, because it is beginning from here. I equal to 0. I less than or equal to n minus 1, because the upper bound is n minus 1. I plus plus. If I do this operation, obviously when the value of I is equal to 0, it enters inside the for loop. Then a of 0, that is 10, is equal to 30. No. Then obviously it comes to the else part, but I do not want to have the else part to be executed. If that is the case, what has to be done here? I have to apply the continue statement. Continue. If I apply the continue statement here, what happens? It skips the execution of rest of the statement. Then this statement is not at all reachable. So if that is the case, I will apply the continue statement here. If I do that, what happens? This condition fails and obviously it has to go to the else part. So let me not consider this else part at all. If that is the case, even if there is no element present in the list, it has to say that the elements are present, but that must not happen. Suppose if the element which I am searching for is not at all present in this list, then it has to display that the searching element is not present in the list. But in this case, I am searching for the element 30. For successful search, it has to return the element which is present in the array. If that is the case, it has to display that a of 0, that is a of 0, 10 is not equal to 30. Obviously, it has to continue that. Then, now I have the value I is equal to 0. If a of 0, that is 10, is equal to 30, or else let me have not equal to 30. If this is the case, 10 is not equal to 30, then it has to continue from here. That is, here, let me have this. A of I is not equal to 30. Then it has to continue executing that. Continue executing that. What is that it has to execute? Continue the iteration once again. Where is that iteration? Here. For I is equal to 0, I less than or equal to n minus 1, I plus plus. This has to be executed here to here. What is the value of I initially? 0. That is 0. A of 0 means 10. 10 is not equal to 30. Yes, it is correct. It goes back again. I is incremented by 1. What is the value of I next time? 1. 1 less than or equal to 5. Yes, again, A of 1. Here, 20. 20 is not equal to 30. Yes, again it comes here, then goes back to the continue statement here. Then I is incremented by 1. It is again next time it is 2. I is 2. A of 2, that is A of 2 is what? 30. 30 is equal to 30. When it is equal to 30, it comes to the else part and displays that the element found. The element found. That is, we have the option of that. We will get this option, that is the element found. What if there is an option for the element which is not at all present in the list? Suppose if I have 10, 20, 30, 40, 50, 60. I want to search for an element 70 which is not at all present in the list. Then we need to consider the worst case scenario of this linear search algorithm, wherein we have this option, that is A of 0, that is 10 not equal to 30. Yes, not equal to 30. Then when it is equal to 1, 20 is not equal to 30. Yes, it is not equal to 30. 30, it is incremented by 1. A of 2, that is 30 is not equal to 30. Yes, it is equal to 30, but I am searching for 70, an item 70 here. Now, 30 is not equal to 70. Yes, it is not equal to 70. Continue. 40 is not equal to 70. Yes, it is not equal to 70. Then, continue. 50 is not equal to 70. Yes, it is not equal to 70. Continue. Then 60 is not equal to 70. Yes, 60 is not equal to 70. Then again continue. It has already reached the end of this statement. What is the value of I next time? It is equal to 6. 6 is less than or equal to 5. No, it comes out of this and it has to print that outside the for loop, unsuccessful search. The searching element or the element which is being searched in the list is not at all present is the message to be displayed. This is how the linear search algorithm works. So, by listening to it, you will say that suppose if the element to be searched is present at the first position itself, we say that the time complexity of this is best because we have found the element to be searched in the first location, very first location. What about the other worst case? Or I can say that omega complexity. What is the meaning of omega complexity? Big O complexity. That is worst case, best case, or the different types of cases. When you want to search for an element which is present at the last position, that is if you want to search for an item 60, then you have to traverse each and every element. Then what is the time taken? n-1 time taken. What is the best case analysis says? Suppose if the element to be searched is present in the first location itself, then it is called as 1. Best case time complexity, it is 1. In the worst case time complexity, it is not at all present, or if it is present in the last position, then it is very difficult to say that the element is not at all present, and the time complexity of linear search algorithm is also not good. But there is one condition, that this linear search depends on only two different types of arrays. That is, whether the array is sorted array or an unsorted array, it is not a matter for linear search. It keeps on searching from the very first position to the last position and says that if the element is found in the list, it says that the element found. Otherwise, it says that the element is not at all present in the list. That is same thing is explained here. It compares the element to be searched with all the elements present in the array. When the element is matched successfully, it returns the index of the element in the array, else it returns -1. If the element is found in the list, it returns the index. Suppose if 30 is the element to be searched, what is the index of that? 2 is the index of that. So it returns this value 2. Because 2 is the index location wherein we can find out the value 30. Suppose if the element is not at all present in the list, then it has to return something, right? What it returns? It returns -1. -1 is an indication that there is no element of such type which is being searched in the list. That's why it returns -1. That is the index which is -1 means unsuccessful search. There is no element of that type in the list or in an array. Suppose if the element is present in the first location, it returns the index of that first location. If it is present in the middle of the array, it returns the middle of the array as the index of that location. If it is present at the last location of an array, then the last location is returned to the user. That is the case with linear search. Next, linear search is applied on unsorted, unordered lists when there are fewer elements in a list. The same thing is explained here. This linear search can be applied to both sorted and unsorted array, whether it is in increasing order 10, 20, 30, 40, 50 or in the decreasing order 50, 40, 30, 20, 10. It doesn't matter. It is whether it is an increasing order or decreasing order, whether it is sorted or unsorted. In case of unsorted, we may have the elements like 10, 50, 30, 40, 10 like that. That is an unsorted array. It is not a matter for linear search. The linear search criteria is always it searches from the first position to the last position. If the element is found during the search operation, it says that the element found, else it says that the element not found in the list. That is the concept you are going to find out in the linear search. Linear search is again a very basic and simple search algorithm. In linear search, we search for an element or value in a given array by traversing the array from the starting till the desired element or value is found. That is from the first position to the last position of an array. Then we will follow these steps. This is an algorithm of linear search. What does the algorithm describes here? We shall see to it. Traverse the array using a for loop. I used the for loop like for I is equal to 0, I less than or equal to n minus 1, I plus plus. So traverse the for loop. If the value matches, return the current index of the array. That is, if the value matches, return the current index of an array. Else, here I had written continue here. Else, what happens here? It comes out of the for loop and prints that SOP. That is system.out.println. It prints that element not found. And prints that -1 here. Right? If the element is found, what has to be displayed here? After executing this statement, once when the item is found, we say that it is present in the list. If it is not equal to this value, it keeps on continuing executing this. When the element is found, this case comes to the else part. Here it displays that the element found. What is that element found? The index of that element. What is that index here? Suppose if I am searching for 30, what is the index of that? 2. 0, 1, 2, third position. It is starting from 0 to 2. So 2 is the value returned to it. So that's how the linear search works. If the values do not match, move on to the next array element. That is, sequentially, it moves from one position to the next position, next to the subsequent positions. Similarly, if there is no match, return -1. The same thing it states that. That is the linear search. Here one more thing you need to understand very carefully and you need to observe it. Sequential order starting from the first element in the given array is very, very important. If you use this word in the examination, you will get the full marks, because the word sequential indicates that the linear search works on the condition of sequentially searching the element from starting to the last position. You will see the distinctiveness of this linear search from other searching algorithms later in the next sessions. It is used for unsorted and unordered small list of elements. It has a time complexity of big O of n, which means that the time is linearly dependent on the element, which is not bad but not a good too. It is a very simple implementation. Very simple implementation. As I have already discussed the logic of that, it is very simple. Now, if you say that the linear time complexity is big O of n, what is the meaning of that? Suppose if there are n elements, that is from here 0, 1, 2, 3, 4, 5, totally 6 elements are there. Now if I want to search the element which is present at the last location, that is 60, this is the first element, then it has to traverse the first, second, third, fourth, fifth, sixth. At most, if it is present at the last location, what is the time taken to execute? How many items are sequentially searched? Indexes? N items or n minus 1 items. So obviously the time complexity is big O of n, because the total number of items present in the list is n. And it searches these indexes sequentially, one by one. So that is why the time complexity of a linear search algorithm is big O of n. That is the time complexity. Thank you very much.